Well, hello everyone. Thank you for having me. It's a big honor today to be with you. First, I'm going to start with this simple question. Who has never heard about the OWASP community? Okay, we have a few number, but I believe most of you guys are already familiar with the community and the projects, its different guidelines and toolings and publication, that all for free. And the goal is to help developers build secure software. In fact, as of today, if you check the official Git repo of this community, we have 1.2K projects. And again, it includes free resources that can be used by developers to build secure software. And it's not the only resource today. We are starting to see more and more organizations working under the same goal, like the OpenSSF, for example, or NIST from the United States, but also ANSI in France, and etc. And again, they operate under the same goal, which is providing free resources to everyone interested by application security. This is all good, but in my opinion, we still don't have a clear answer when it comes to this type of question, which is simply how we can integrate all of these resources, all of these tooling into our organization. And you may get hundreds of answers and many approaches on how to do this. And in fact, a few years ago, we had this DevSecOps concept and how it can help you to solve all your security problems. And you may also came to something called the shift left concept, which is an approach to integrate security within your projects. And there is also this research article from the IBM System Institute, which claimed that bugs are 6 more expensive to fix on the implementation phase than in the design. Turns out that this article is a big, fat lie. I mean, you can check the fact by yourself, and after some research, you will find out that this research doesn't exist, and the IBM Institute, even if it exists, it's just an internal program made for IBM employees. And the last point is, there is no data that confirms this assertion. Let me repeat this again. There is no data that confirms this assertion. I mean, I'm not against the concept of shifting lefts. It totally makes sense. When you fix an issue earlier in your product, the less likely it will propagate deep down in your code and create dependencies everywhere that you need to fix later on. But why do most of companies today that have invested millions on security tooling to achieve this DevSecOps concept are still struggling with basic security issues into their products? And I don't want to sound pessimistic from the beginning of this talk, but if we have some penetration tester in the room, I think we all agree that it's quite rare to do a security assessment without finding any security issue or anything to write in the final report. Also, now with the shift to AI and the LLMs and all this crazy discussion on do we need to replace developers or something else? As someone who works on a daily basis with developers, do I have to maybe change the way I do my work, or maybe find another job? So this is basically what we are going to cover in this talk, on building a modern, scalable, and an effective application security program. A bit of background about myself. So again, my name is Abdessamad, and I'm an application security engineer and educator. I've been working a lot and before on penetration testing, so I'm certified penetration tester since 2014, and I used to do a lot of security assessments. And 4 years ago, I switched to different role where I work on a daily basis with developers and helping them with their products by providing the right security requirement and doing a lot of security review and acting as the subject matter when it comes to security topics. I'm also a contributor of the OWASP community, and I had a chance to contribute to different projects like the Mobile Security Testing Guide, the OWASP Proactive Controls, and I'm also founder of Keycloak Academy, which is an e-learning platform on how to use this solution for identity and access management. And finally, you can reach me by on LinkedIn. So as you may notice, I had a chance to work on both sides of the industry, and this is basically what it feels like. And the thing is, you need to have or see things from two different perspectives, because as a security folks, we tend to see everything as important, but we also need to take into the account the developer perspective, because they have their own workload, their own deadlines to fulfill. And I believe this is the way we need to approach this kind of topics when we want to integrate application security into the SDLC. And this is basically what we are going to cover in this talk. So I'm gonna present some of the latest trends in application security, and also provide you with some tips on how to scale your application security program, especially when we are working on large environments. And this talk isn't a silver bullet. I'm not claiming that it will solve all your security problems. I'm just going to explain the things that work for my own organization and showcase the things that work and also the limit of it. And it's completely vendor neutral. In case I mention any vendor's name, it's more often like a habit, and it's not, it's definitely not a sales pitch. With that said, let's jump right to it. Let's first start with the global definition of what is an AppSec program and why do we need an AppSec program. An AppSec program has an objective of reducing the number of vulnerabilities in your products over time by building a repeatable, sustainable, and proactive security practices that are embedded seamlessly within your product lifecycle. And with that objective, we do a bunch of activities, a bunch of things. The goal here is to combine and split the problem into different areas instead of focusing only on a specific approach to deal with application security. And each component of an AppSec program will require at least one talk to cover it in detail, but in today's presentation, we are going to focus on two main components, which is threat modeling and detection, simply because we are seeing big change on these two components over the last year or even the last month. Okay, let's start with detection. The goal here is to be able to detect security issue into your existing products or even new ones. And here we don't want to rely anymore on manual assessment like penetration testing or manual code review, simply because it costs too much. And also because the development these days is more into rapid, agile approaches and shipping things more frequently, not like the old manual release where we used everything, we script everything and do everything on a memory basis. The goal here is to be able to keep up with the velocity of change and build on the existing process and integrate in all of these. So how we can achieve this, how we can implement security testing when working with modern teams. In order to answer this question, I'm going to walk you through the history of software security testing. Software security testing goes back to the 30s, where Alan Turing and his team worked on the bomb machine in order to break the crypto system Enigma. They even made a movie for this, which is a cool one, by the way. And it was this big giant machine with hammers and cranks and wires everywhere. And it was a big thing back to this period, because it did change the course of events during the Second World War. And then around the 70s, we had a tool called Linter, which was the first static analysis tool, and it did lay the ground for many other tools that will take as an input your source code and point out exactly where you have security issues. And innovation did really accelerated around the 2000s. Here we have most of the tools that we see today and use today on the market. And the main issue with this kind of tool is that they are resource intensive and they require a lot of memory resources and CPU in order to execute the security scan. And it's even and you need some time to wait for hours or even days in order to scan your whole code base and get the scanning reports. And that's why we have new generation of static analysis tools which can be used to run fast scans focusing only on the important security issues. So as a developer, I can use this kind of tool to verify my merge requests before I am allowed to push the code to the main branch. And this is something that can be done in few minutes or few seconds. Parallel to this, we had other subcategories of software testing tools like software composition analysis, which aims to detect or scan your projects in order to detect what external dependencies are used inside your projects, and then verify if these dependencies have security issues and CVE. Also, we had tests, which is automated penetration testing. And here the approach is different from static analysis because we interact directly with the application by sending HTTP requests, analyzing the response, and deciding from there if there is any security issue to fix. And last type of tools is interactive testing. Here the approach is completely different and it combines both static analysis and dynamic analysis. The idea here is to instrument your application so we have deep visibility on the runtime, and parallel to interactive testing, the tool will alert you whenever you have security issues. And this sums up the innovation we had and many different research we had regarding software security testing, from the old days where we used to have big machines with wires and cranks, etc., to the latest technology in terms of software security testing. With all this tooling, with all this option we have now on the market, which one is more relevant today? Which one deserves to be integrated into our organization? Do we have to put all or purchase all these tools, or maybe we need to pick one depending on our specific needs? And whatever solution you may pick, there is some success criteria that you need to consider before trying to deploy this kind of tools. The first one is integration. Here, as a security folks, we need to understand and accept the fact that these developer teams and DevOps teams has already their tools, they have already their pipelines and workflow to build the software. So from a security perspective, we don't need to change the way this team works and operates, but instead we need to first understand the process and build on top of it in order to integrate in all of these. Then we have the implementation speed. As I mentioned earlier, the development these days is more focused on the DevOps life cycle and shipping things at high speed. So we need to be able to provide tooling that match the velocity of change we see in DevOps environments. Then we have the ease of use. As a developer, I don't want to change the way I work. I don't want to change my setup in order to install your tools. I'm already happy with my own setup, and I'm not going to change it just to run security assessment. So from the security perspective, again, we need to figure out how to propose a developer-friendly solution that can be seamlessly integrated into an existing environment. Then we have accuracy. This is very important because most of the tools that we saw later on may generate false positives, and this can be acceptable at some level, but if we continue to push every time false positive and not accurate results, this may impact the trust foundation we have with our developer teams. So it's very important to leverage tool or use tool that provide accurate results. And then portability. Here the goal is to be able to run my security tooling basically from everywhere, whether it's locally, from the CI, as a web service, as a container image, etc., etc. I think there's a decent between. So we had the same question almost 6 years ago, and our decision or our choice was to start with dynamic application security testing. But down the road, we noticed that this is something very difficult to set up and scale. And simply because it has a lot of requirements, you need to configure account, you need a stable environment to scan, and it cannot guarantee a good test coverage, because the first step of dynamic scan is to map all the entries of your application, which is something very difficult when you want to scan a single page application. And sometimes it will take hours before getting a scan report, especially when you scan a large application. And when it comes to fixing issues, again, it's very complicated because the developers need to inspect the code and figure out where he needs to fix the issue. This is why we decided to switch to static analysis, and in my opinion, it's one of the most used tool today by many organizations, simply because it's very simple to deploy. The only requirement is the source code. You can also achieve 100% code coverage, because scanning the whole code base will allow you to spot on any security issue. You can run at any time. And also in terms of remediation, it's very straightforward. In the report, you will get exactly which line of code you need to fix without having to invest much effort. Okay, now we decided to go, for example, with SAST. The next question is, where do I need to put or configure my tool? And here, there is different possibility. And if you ask your security vendor, he may told you to use his IDE plugin to run security testing. And the idea is to be able to flag security issues while the developer is building his own code. This in theory may sound interesting, but imagine yourself working as a developer with a tight deadline. You just need to finish this merge request and go home. And on the other side, you have mini tool installed on your IDE in your development environment, telling you, no, you don't need to do this, you don't need to do that, and sometimes the results are inaccurate. This can be overwhelming from as a developer experience, and also for the security teams, it's not that easy to install and configure, simply because developers use different technology, use different IDE, and it's very possible to cover all these toolings. So this is very terrible idea when you want to integrate security tooling. Next option you may have is CI/CD integration. As of today, most of the vendors today provide plugins that you can install on your Jenkins, for example, in order to run security, automated security scans. But if you use this kind of approach, you may end up with pipeline that look like this. And here you are just dumping a bunch of tools to your developers, generating hundreds of results. No one will review, no one will be interested by this kind of approaches, and it will create definitely a chaos in your DevOps pipelines. So that's why we have now new approach. Again, the old way to do, just to sum up, the old way of doing security integration, either inside the CI or in the IDE, it doesn't guarantee you will achieve 100% coverage. It can be easily bypassed. On the Jenkins file pipeline definition, for example, you just need to switch the option that runs security scans, and it will disable all the scan that you have configured. And also the fact that we have decentralized configuration, it's very difficult to update a settings or make a change to the way you configure your scans. And that's why we have a new approach which is called pipelineless integration. Pipelineless security, it's very simple. The idea here is to configure tools that will watch events from your SCCM tool. And whenever, for example, you have a new code that has been merged to your Git repo, this will automatically trigger scans somewhere that will verify your code instead of doing this directly in the CI, and then it will provide isolated feedbacks directly to the person who did the change. And this kind of approach can be used to achieve 100% coverage from day one. Technically, you just need to configure a webhook for each repo, and then from there, the security tooling will be able to automatically trigger analysis whenever we have a change into your Git repo. And the interesting thing about this approach is that you can manage everything in one place. So once you get all your security tooling from the CI and have them in one place, you can have full control on the configuration. You can make change frequently, etc., etc. And one interesting thing here is using this approach, you can provide fast and private feedbacks. So usually when we run security scans, we send the report directly to the mail address of a dev team. But this is not something we can do, for example, where when we scan, when we detect secrets in the code, you can't push all this, the secret to a generic mail address with hundreds of people. Here we can, by watching the webhook, we can detect who made the change, who pushed the secrets, and from there send isolated feedbacks and private feedbacks, and also trigger other process to, for example, reset the secret that has been leaked. In order to implement this, again, you just need to configure webhooks that will watch for events that happen inside your Git repository. And from there, you will trigger a workflow that will run security assessment. Here you have two main options. Either use custom script to code your workflows, or use a solution that can handle this, like Kestra, for example, which is an open source solution to implement your workflows. And the cool thing about this kind of platform is that you can reuse components into different workflows. You can also define these workflows as code, as YAML files, so it's very easy to update and maintain. And this is basically our existing, the workflow I'm using within my organization. I'm not gonna explain it directly on the slides, but this is something that we can configure only as code, so it's very easy to understand, and also we can, again, reuse different components into different workflows. Let's see this now, this workflows in actions. And how we did implement pipeline security in our case. So here we have a simple setting file that contains some parameters related to this specific project. And here the starting, we start just by pushing a vulnerable code to our Git repo. Okay, so here we push the code and we commit the code to this remote Git repository. And behind the scene, we will have a tool that will scan the code and then detect if this new change contains any security issue. Here the code has been merged into the remote branch. And again, behind the scene, we have already a report, scanning report, ready to share with the corresponding developers. And it will be sent by email. So as a developer, I don't need to check on a different tool. I will have the information straight away to my mailbox. And here for each security issue, we'll point directly to the Git repository. So again, we don't need to view the issue in any external tools. We are just reusing the existing one to provide detailed information and specific information about the issue. So here we understand that there is SQL injection issue, and parallel to this, we open a Jira ticket because everything is done using tickets, especially when working with dev teams. And inside the tickets, we will have all the necessary information in order to fix this issue. And finally, we have a Confluence page that contains some simple secure code to reuse in order to fix each specific issue. And basically that's it. So parallel to this, we tried to collect some metrics in order to evaluate the effectiveness of this approach, and we did notice that over time we had a significant we had low number of issues over time, which was really interesting. And regarding the time to fix or the effort required to fix an issue, we noticed that it's also going down, because as developers start to work on security tooling, they started to get more and more familiar with classic security issues. Okay, let's move on to the next component, which is threat modeling. Most of classic threat modeling approach will require you to draw a diagram like this. This is, for example, in the STRIDE methodology. This means that you need to convert all your existing documents, all your diagrams into something similar to this. And I guess, and we all agree that this is a painful task, especially when you are working in a team with huge workload. And it's a very slow, it's a very rote. There is no better way to make security the worst part of someone's job. And it's very complex. And we cannot use this kind of approach to review every change. And it's difficult to scale. And that's why we have now a new approach that try to leverage AI and LLMs in order to at least automate the repetitive tasks. It might seem complicated at the beginning to use this technology and embed this technology into your existing workflows, but we have today many frameworks that can make it easy for us, especially for someone who doesn't want to care much about what's happening behind the scene. Like, for example, the LangChain framework. I'm not going to dive into the significance of each component, but here the important one are first the LLM's integration component. It will allow you to integrate with different LLMs like OpenAI, Claude, etc., etc. And you can even change and combine these LLMs in one workflow. And third component is document loaders. It's basically really interesting because it will allow you to enrich LLMs with your own data. So, for example, if you have document architecture or security policies specific to your organization, you can inject this. You can reuse this information along with an LLMs, which is very powerful. And last component is prompts. Prompts will be used to give instruction to LLM agents in order to do a specific task for you. And actually, there was a nice research that has been done to test how LLMs can be good at performing threat modeling. So the entry point was a basic application called Meal Planner with a front-end API published behind the gateway and a database to persist user data. Here, the diagram was provided as C4 model language, which is a way to represent a diagram as code in order to make it easy for LLMs to understand and use it as an entry point. So along with the architecture diagram, we provide also the project description and also a test user story to the LangChain framework, which is backed by different LLMs. And instead of directly asking the agent to do the security assessment or the threat modeling in one question, here we split the question or the task into two basic prompts. The first one will just list the data flows and different connection between the different components. And the second will review each connection in order to detect potential risk. And the result of this experiment was a bit interesting. Sometimes some LLMs did provide relevant results to the scope, but they were so generic. Here, for example, the mitigation is to use HTTPS, which is not something specific to this use case, but it's applied to any kind of architecture. And also, we had interesting results with different models like Claude, for example. So here we were able to get a valid threat, which is flowed in the API gateway. And one interesting thing is that he managed to understand that we already have a security feature to mitigate the risks. It was mentioned somewhere in the project description. So we were able to understand this and use it as a component to mitigate the risk. And he did even challenge it, because in the project description that has been provided in this study, they didn't provide much details about how this feature is implemented. So he provided as a recommendation to review this implementation and make sure that it will mitigate the risk. Also, last week, the OpenAI security team released some bots that they have been using to automate some of the most common security tasks. And one of the agents is the Slack bot. So this one basically acts as an entry point to product team to decide if a new product or a new feature need to undergo a security review. This is really important because as a security folks, we always get requests from different teams. We don't know which one we need to handle first. By using this kind of approach, I believe we can focus only on the critical chains and the critical applications. So what the future looks like with LLMs and threat modeling. Definitely this kind of technology will reduce the workload, especially when it comes to repetitive tasks. I think the root part of, let's say, threat modeling need to be done by machines, not by human. And it's also important to customize LLM frameworks and design our prompts, but it's definitely worth it because it will save us hours, and it will be more interesting to do this using LLMs than having someone from security to do it every day. And last point, in order to make results more accurate and more relevant, it's important to combine LLMs with RAGs and also decision tree. This will definitely help and prevent AI or LLMs from hallucinating. Okay, let's do a recap. In order to build a scalable, effective, modern security program, first, regarding the scalable part, I think it's interesting to not put everything on the CI. This will only slow down your process, and it will be difficult to manage. It's better to implement external workflows that will just watch events from your existing dev tools, and then send private security feedbacks directly to the corresponding team. And this will definitely minimize the configuration efforts on dev team side. Regarding effective, it's very important to collect data and metric as much as possible, because it's the only way to detect if you are going into the right direction. And regarding the last point, I think it's time to invest more and more in LLMs, especially on the AppSec field, to automate basic and repetitive tasks. This will allow us to focus only on things that matter. And regarding the last point, I definitely recommend reading this book, Life 3.0, which has been published, I think, 6 or 5 years ago. In this book, we are trying to imagine how life will look like at the age of AI. And it brings some important question about how we can inject this technology into our daily lives. As an AppSec engineer, some of the question I ask myself, do I have to maybe automate the most repetitive tasks and focus only into the important one, or maybe delegate everything and just chill and relax? And the book explore many other possibilities. So I would definitely recommend checking this book. And why do we need to ask this question today is because the earlier we know where we want to go, the easier we'll be able to attend it. Again, my name is Abdessamad, and it was a pleasure speaking at your conference, and I'm looking forward to have your questions.